Alright, let's go ahead and graph y equals 3/2 cosine parentheses 2x minus pi. I'm just going to identify my letters, and by doing that, I'm just going to write my letters above or below this. Y equals a cosine b, then the parentheses x minus c, and then we learned that if you do have a d value, it would be out here, and then I'm encouraging you guys to put your d value way on the front. This tells us that your a value is 3/2. Your b value, now in the original problem, the student who doesn't factor or take out the greatest common factor thinks the b value is 1. Here is your hint to know what to do. Do you see the number in front of x? What is it? 2. So if you pull out a 2, it's 2 times x equals 2x. Now, if you get stuck on this part, what goes inside the box? Of course, you already see the answer, but it's 2 times the box equals pi. And just to solve for the box, you get the box equals pi over 2. Do you see that? That's what goes there. So when you distribute the 2, 2 times x is 2x, and 2 times pi over 2 is, make it a fraction, 2 times pi, 1 times 2, you get 2 pi over 2, which is pi. So our b value is 2, and your c value is pi over 2. Now, you can get some characteristics from this already. Now, think about this. Our d value is what? 0. Okay, so it's not going to be shifting up or down. Okay, so a lot of you guys are using the a value to figure out what you put on your y-axis. That is true as long as there's no what? There's no vertical shifts. Pi over 2, left or right? It's going to go right. Remember, add to x, go left. Do you see adding right here? No. So you're not going left, you're going towards the right. What does the b value help us find? The period. You put a 2 in there. Your period is going to be pi. That essentially means that your graph is going to finish one graph by the end of pi, and our amplitude is the absolute value of that, which is 3/2. Okay, this part is crucial. Because you have parentheses, because you have what, class? You have a horizontal or phase shift. What do you have to do? Everyone say to the right.
To the right.
Which direction?
To the right.
Everything to the right of the trig function. It does not matter if you took the original or if you factored it. Are we okay? Yeah. Let me make that clear. You can pick the yellow or the pink to put in here. I chose to put the original. If you chose the pink, you should get the same answer as I do. Okay, this is where students are struggling. Over the years I've seen. To solve for x. Class, do you divide by 2? You could, but you would have to divide this expression by 2. So, let me put this out here. To simplify, you go down on PEMDAS. This is my little trick. To solve, you go from the bottom to the top. So normally, if I'm trying to solve for x here, I need to do addition and subtraction first. So I'm going to add pi. This would give us pi less than or equal to 2x less than or equal to 3 pi. Now I'm going to divide by 2. Do you see how I'm moving up here? So my answer is going to be, my graph's going to start at pi over 2 off the origin and end by 3 pi over 2. Raise your hand if you got that. Okay. And this makes sense because it's being shifted off the origin by pi over 2. That's why it's starting at pi over 2. Let's go ahead and make our graph. So originally we would have 5, right? 1, 2, 3, 4, 5. But because it's being shifted to the right pi over 2, I'm not starting at the origin, I'm starting at this one. So now I have to add one more. 1, 2, 3, 4, 5. I'm going to start here at pi over 2. So this is your start, and this is your end. 3 pi over 2 goes right there. All right. Class, what's 1 plus 3? And 4 divided by 2 is? So this is 2 pi over 2. We're okay? Now, this is going to get messy, isn't it? 1 plus 2 is what?
3.
And 3 divided by 2 is? So it's really 3 halves times the half you already have. It's 3 over 4. Let me show you how I got that. If I double all of these to get equivalent fractions, class, what do you get? 2 pi over 4. 4 pi over 4. They're equivalent, right? Still pi, it's still pi. 6 pi over 4. Do you see why now? 2 plus 4 is?
6.
I said 2 plus 4, right? 2 plus 4 is 6, and 6 divided by 2 is? 3. So I have 3 pi over 4. So really I'm counting by what? And the numerators? 1s, right? So this will be 5. I like to go back and circle the ones I'm going to be using. You could work with all those as long as at the very end you reduce them. So I have pi over 2, 3 pi over 4. This is essentially pi, 5 pi over 4, and 3 pi over 2. So I have x, pi over 2, making my table of values here, 3 pi over 4, pi, 5 pi over 4, and 3 pi over 2. Yesterday we talked about how writing words on the side might be helpful as you guys evaluate these. Put your finger at our starting point. Okay, so you're inside the parentheses. Look, PEMDAS. Or you can do this one. Doesn't matter. I'll do the original one. Which one should we do first? If I have x, should I subtract pi or multiply by 2? Inside the parentheses, you still do order of operations to simplify. Are you following? So would you add or multiply first? You're going to multiply. So we're going to multiply by 2. So I'm going to write the words multiply by 2. Multiply by 2. So you make this a fraction. 2 times pi is 2 pi. 1 times 2 is 2. So 2 pi over 2 is just pi. This becomes 6 pi over 4 or 3 pi over 2. That becomes 2 pi. That's a 2. 2 times pi is 2 pi. This is 10 pi over 4 or 5 pi over 2. And this will become 6 pi over 2 or 3 pi. Now I'm going to go back up. I'm using the original equation. You can use either of them. Now what do I do? We just multiply by 2. Now you're going to what? Subtract pi. So you can use symbols, or you can also over here make sure know what you're doing. You're subtracting pi. These values subtracted by pi is what? So 1 pi minus 1 pi is going to be 0 pi. Okay, this is where you might need your equivalent fractions. And You could do it over 1, right? 1 over 1 or 2 over 2. Which one? Can you point to the person? Do you know it or no?
Yeah.
That one?
Yeah.
Okay. Just leave that one on the side. I know. I have the paper.
Oh, okay.
So 3 minus 2 is what? So that's going to be 1 pi over 2. You guys okay on that? 2 pi over 2 is equivalent? Yeah? 2 pi minus 1 pi? 5 pi over 2 minus 2 pi over 2? And 3 pi minus pi? Up? 2 pi. This one I call the golden row. Why do I call it the golden row? What is that? The quadrantals. You always want to get this golden row. Does that make sense? Because you don't know how to evaluate, they'll become very difficult. That weren't even on the unit circle. So, okay. So we got x multiplied by 2, subtract, and now we do what? We're going to evaluate cosine. Let's write that. Evaluate at cosine. Evaluate at cosine. Cosine at 0? Pi over 2? Some of you guys have already memorized that. Again, you can just go back to the unit circle. And then the last thing we need to do is what? Multiply by 3 halves. So again, to review, we are going from right to left. It's just in there I had to use order of operations. So multiply by 3 halves. Class, go ahead and multiply. Okay, so this kind of tells me, this last row tells me what to write on my y-axis. My y-axis has 3.5, so let's just say call that one 2, 1. So that would be 3 halves, right? Let's pick a bright color. So now I have 3 halves at, pay attention, pi over 2. Do you see the order pair? Pi over 2, 3 halves, because there is the horizontal shift. 0. Pi at negative 3 halves, or negative 1.5, between negative 1 and negative 2. 5 pi over 4 is 0, which is the x-intercept, and 3 pi over 2, and then 3 halves. Here's my graph. Let's put all the characteristics back in so you can see where they go. The amplitude is 3 halves. The amplitude is from the max to the midline. The midline, I'm running out of colors, is actually your D value. We learned yesterday's lesson. This is the midline. The period was pi. Do you see this? That means from this distance, pi over 2 to 3 pi over 2 has a distance of 1 pi, right? 3 minus 1 is 2, so 2 pi over 2 is pi, which means it finishes there. We know it's shifted off the origin by pi over 2, and then it didn't. This midline does not go up or down any.